Alright, hello and good afternoon. Hope everyone's having just a dandy Sunday. Today we're going to be talking about databases, but as always, I should remind you, my name's Andrew Wynn, this is ISA 4220, and we are in the beautiful spring semester of 2018. So, let's talk about database. So, what is a database? So, database is where all your information is stored. It's a central location that holds all the data, or you can have users or admins view and modify anything at their will. So you can make a database completely tailored to how you want your information stored and functioned. DBNS is a database management system. Um, this is where data users and programs interact together. This offers an organization data structure. It increases data integrity. There's in this system there is data redundancy, which is basically you can have data stored in more than one place. It's kind of like the cloud. So if you had your computer backed up to the cloud, and your computer gets wiped, or there's a virus or something, and all your information goes away, you have a second set on the cloud. Always have your information backed up. That's just a rule of thumb because you never know. Technology is crazy. Things can disappear. Things can be taken. Things can crash. Um, Another thing is database management systems can have access controls put on, and this lets certain users, so authorized users, into the system to make modifications. Something I would recommend when you're using a database management system is to use the least privilege function, so only giving admins the ability to edit and modify data and what can be changed on the system. That's just one step you can use to make sure everything's more secure. Moving on, database models. There's five main models. You have relational, hierarchical, network, object-oriented, and relational. And so I think, in my opinion, relational is going to be your most popular. This is where you have your typical columns and rows to organize your information. It's typically in a table format. Then you have hierarchical. You have your most important thing on the top, and then you kind of break it down by subgroups. I would say network and hierarchical are pretty close to each other in how they're laid out. You can see in this picture I have here on the right. The network model is very similar to the hierarchical model. It has one thing at the top and it breaks it down. But in the network model, what I've taken away from it is you have a main concept, and you have two main subgroups, and then you have subsets from each of those. Unlike hierarchical, where you could have multiple subgroups. And then you have object-oriented models. This is where you see this is a little bit more dynamic, as you can see in the picture. You got charts and you got tables, but this is where you can also, from my research, it looks like you can have videos and pictures and sounds be stored in these models. An object relational is the last model, and this is more where it's an object-oriented database software. So those are the five models. So moving on, I'm sure we're all scrambling to finish our Linux boxes today, but something we're going to have to add on next time is Postgres SQL. This is open source. Um, this is going to be our database that we're installing on our Linux box. Um, I think it's, from everything I've done research on, it just is extremely reliable. Um, it's standard compliant. There's multiple database types, so you can do everything from pictures, videos, sounds, files, you name it. Postgres can store it. Um, Interfaces. You can have multiple different, I guess, languages on there. So you could have anything from like C++, C, Ruby Pearl. You could have also .NET. These are just a couple of the many interfaces that you can run on there. Something that I thought was cool about the data sizes, it's unlimited. Um, so you can send whatever file or hold whatever file. It might take forever to download, but um, it can take it. So these are a couple hardening recommendations I have for Postgres. And so something that you really should be doing for everything is keeping your software up to date. And if you guys forget how to do that, you just go into your Linux box, make sure you're in sudo, and then just apt-get update. You always want to keep your software up to date, because if you don't, that can be just a vulnerability that's unnecessary. Another thing is have user roles. When you're running a database, it's always good to distinguish whether you're an admin or you're just a user, because if everyone has the same level of access, I mean, first of all, that's just a horrible idea. Don't do that. Least privilege, like I said in a couple slides ago, only give people access what they need to do to complete a task, because if you have the gates open for everything, I mean, that's just calling for an issue there. Some other techniques are data masking and encryption. Make sure the database is encrypted. Let's see, what else? Oh, I would also recommend using like a AAA model for the authentication, authorization, auditing. Just taking those three things, and making sure you have certain levels of access to each part of the database and certain clearances for each part of the database. And then, yeah, that's pretty much all I have today. We're only doing one thing, so sorry I can't bless you for a whole 15 minutes, but you guys take care and have a great Sunday.